All right, baby, so let's go ahead and start this review with the units 1 and 2 today. All right, a gardener wants to use 62 feet of fencing bought at a garage sale to enclose a rectangular garden. Find the dimensions of the gardens if its length is to be 4 feet longer than twice its width. So the total perimeter would be 62. And then it's talking about length and width. If its length is to be 4 feet longer than its width, so I have info about the length, but I do not have info about the width. So that would be my x. So backward word, whatever goes after that you write first, twice its width, so that would be 2x. And then longer than would be plus 4. At this time, I would definitely make a picture because it's hard for some of us to see it. And there's 2 widths and 2 lengths. Now for perimeter, you have to add all the sides up. So let's see what we can add over here. 2, 4, 5, and 6 x's. 4 and 4 is 8, and that would equal 62. After that, you can either go to equation solver, and you can just say the steps to solve this would be minus 8 divided by 6 minus 8 because it's plus, divided by 6 because it's multiplied by the x, and x equals 9. Now I have to figure out the dimensions. So the width is 9, but I'm going to have to come over here and plug in the 9 with the x, and then 2 times 9 is 18, plus 4, 22. So the dimensions would be 22 and 9. A restaurant owner needs to purchase some tables, chairs, and dinner plates for the dining area. She plans to buy 4 chairs, 4 plates for each new table. She also plans to buy 20 additional plates in case of breakage. If a table costs 100, so that would be for a table. A chair costs 50. And a plate is 5. How many of each can she buy if she takes out a loan for 6,500? So whatever she does has to be equal to 6,000. Whatever the equation has to be equal to 6,500 because she only has that amount of money. So what I would do is I would figure out how much she would spend on each table and each dining set, which would be 1 table, 4 chairs. There's 4 of these. It says it right there, 4 plates and 4 chairs, and then 4 plates. So 4 times 50 would be 200. 4 times 5 would be 20. Therefore, on each one of those, she's going to spend 100 per table, 200 for chairs, and then 20 for plates. So the grand total for each one of those dining sets would be 100 plus 200, which is 300, and then 20, which would be 320x, because I don't know how many tables I'm going to buy. I don't know how many sets I can buy. I'm sorry, not tables, but sets. All right, so she also plans to buy 20 additional plates. So the 20 additional plates would be $20. I'm sorry, 20 plates. Let me erase that. And then each plate would be $5. So that's 100. So whatever it takes me to buy a dining set times how many dining sets plus the 20, that should be equal to 6,500. Now I can go to equation solver, or my steps would be take away 100 because it's added, divide by 320 because it's multiplied, and I can buy a total of 20 complete diamond sets. All right, the first part of California's magnificent 17-mile drive is 1 mile longer than the second part of the drive. The final part of the drive is 1 mile longer than 4 times the length of the second part. How long is each part? So if you read, it has 3 parts. I got to figure out how long is each part. It says the first part is 1 mile longer than the second part, so I have information about the first part. It says the final part, which will be the third one, is 1 mile longer than 4 times the length, so I also have information about the third, so I don't have information about the second part of the race. So let's go back to the first part. The first part is 1 mile longer than, that's your backward words, 2 part of the drive, second part of the drive. So if it's 2 miles longer than the second, it would be x plus 2. The final part of the drive is 1 mile longer than, backward word, 4 times the length of the second part. So 4 times the second would be 4x. If it's longer than, it would be plus 1. And then the total would be 17. All right, so let's add part 1, 2, and 3 and see what we got. We got 4, 5, and 6 x's plus 3 equals 17. I'm sorry, plus, this is a 1, sorry, is 1 longer. Sorry about that. Which means this would be not a 3, but a 2. So let's do it again. I put a 2 in here instead of a 1 when it was 1 mile longer. So it is 4, 5, 6 x's, 1 and 1 would be 2. So my steps would be take away 2 because I added, divide by 6. So x equals, you can do this in equation solver too, 2.5. Okay, which means this part is 2.5. But that part is 2.5 plus 1, which is 3.5. And this part is 4 times 2.5 plus 1, and that equals 11. And when you add it, they should be equal to 17. And that's 11 plus 2, 13 plus 3, 16, and then 0.5 and 0.5 would be your 17. A rectangle is formed by placing 2 identical squares side by side. So I have 2 squares that are placed side by side. Now what's special about a square is that all sides are equal. It tells you if the perimeter equals what is the length of each side of the square. Now what's special about a square is that all sides are equal. You don't know the sides, but you do know that they're x's. Now the perimeter does not include this side over here because the two squares are placed together, so we lose that side. So the equation would be 1, 2, 3, 4, 5, 6x equals 90. This is one of those that without a picture is really hard to see. So now we divide by 6 and x equals 15. In a certain rectangle, the length is 3 inches more than the width. So I have info about the length, which means that I do not have info, probably won't have info about the width. So the width is x. 3 inches more than, that's your backward words. So the width would be x, more than would be Now, the length is increased by 4 inches. So now this is increased by 4. Let me write it separately because then I don't want to get confused. I'm going to put it with a different color. So if I add 4 to this, it would be x plus 3 plus 4, which actually in reality would be x plus 7. And the width is increased by 2 inches, so that is increased by 2. The perimeter of the new rectangle is 78. So now I make a picture because sometimes it's hard for you guys to see that you have 2 lengths and 2 widths. So start making those pictures. Now this new perimeter equals 78 inches. So let's see. 1, 2, 3, and 4, because in the perimeter I just got to add all the sides. And then 7 and 7 is 14, plus 2, 16, plus 2, 18. And then to solve for x, my steps would be take away 18, divide by 4. And x equals 15. I want to make sure that this is my answer. It says find the dimensions of the original rectangle. Okay, so the dimensions would be 15, and then 15 plus 3 would be 18. So the dimensions would be 18 and 15. All right, to solve for y. I'm sorry, I'm not solving for y. That's silly. I'm solving for y. Yeah, I am solving for y. Crazy. Okay, so x divided by y plus 9 equals n. So I'm going to take away 9 first. That gets rid of this. So I'm going to have x divided by y equals n minus 9. Now, the y cannot be my denominator, so I'm going to have to put it at the top. So if I put it at the top, I'm going to have to multiply by it because it's divided. So I'm going to multiply it over here, which cancels it over here. But when I multiply it over there, it's multiplied by everything. So now I got x equals n minus 9 times y. Now, this is multiplied by the y, so to get rid of it, all I need to do is divide by 9, n minus 9. Now in here, it's canceled. So then I get that y equals x divided by n minus 9. All right, let's go to the next one. In this one, I have to do C. So I'm going to get rid of that plus 32 by a minus 32. That's canceled. So I have that f minus 32 equals 9/5 C. To get rid of that 9/5, I'm going to have to multiply by its reciprocal. So 5 at the top, 9 at the bottom. If I do it on this side, I have to do it on the other side. That cancels that, and that cancels that. So I get that C equals 5/9 F minus 32. And that's it. You can leave it like that. Okay, the graph shows the cost of a phone call depending on the length of the phone call in minutes. Okay, so the independent variable will be the minutes. The dependent variable would be the money. The more that I talk, the more money that I. Okay, so it starts probably at 0.9. And we got to figure out the rate of change. Okay? So pick a point that you can read. I'm going to pick this one. One right there. Okay, so the rate of change over here would be y divided by x. The y is 4 divided by 5. And then come to your calculator and say 4 divided by 5.8. You can change it to a decimal if you want to. Okay, what's the meaning of the y-intercept? Over here, I'm not going to write it, I'm just going to say it. That at 0 minutes, I still have to pay them 90 cents. And what's the meaning of the x-intercept? That the x-intercept would be negative if that line continues. The x-intercept would be 0. Now, in this one, the meaning doesn't really make any sense because you don't talk, you still have to pay 90 minutes. So if that is 0, that's still going to be 0 as well. So let's go to the next one. Joe has an after-school job at the school sporting goods store. He makes $9.50 an hour and never works more than 20 hours in a week. Okay, so what's the independent variable? What's the one that I can change? I can change the hours that he worked, and then the money that he gets paid would be my dependent variable, because the more hours that I work, the more that I get paid. My equation would be y equals 9.50x. Now this is important because that's your limit. It doesn't work more than 20 hours, okay? So I'm going to make my graph because without my graph I cannot see the domain and the range. These are the hours and this is the money. The domain is my x, which are my hours. He works from 0 hours to 20 hours. That's it. Now what's my range? Well, if he doesn't go to work, he makes 0 money. But if he works for 20 hours, which is your maximum, then it would be 950 times 20, because I'm looking for my range for my money. And that would be $190. It is continuous because you can work half of an hour. Okay, Oscar had a summer job that paid $8.50 an hour. He worked between 15 and 35. Now this is the same one, so same scenario. Hours, money, but now the equation changes. It's not 950, is 850 an hour. Now the domain, which are my x's. How many hours does he work? Where he works from 15 to 35. So 15 to 35. And then I got to figure out how much money I make between 15 and 35. He can work a minimum of 15 and a maximum of 35. So now I'm going to say for 15, it would be 850 times 15. And I believe that equals $127 with 50 cents. And with 35, it would be 850 times 35, and I believe that's 297.5. And again, the graph continues because you can work for half an hour, even 1/4 of an hour. All right. So Emma Service Club is raising money by wrapping presents in the mall. The club will charge $3 for each present wrapped. Okay. So the independent variable is what you can change is the number of presents that you want to wrap. The dependent variable is how much money you're making out of them. The equation is y equals 3x because you're charging $3 per present. Now, I'm going to go ahead and do my graph because I cannot do it without, I have to see it. This is the presents, and this is the money that I make. I don't have to wrap any presents, and I can wrap an infinity amount of presents. If I don't wrap any presents, I don't make any money, but the more that I wrap, the more that I make, so that would be continuous. That would be infinity. Now, to figure out if it's discrete and continuous, take a look at your x's right here. Can you wrap half of a present? That would be no. So the answer would be discrete. You cannot have half of a present. That cannot happen. Wrapped. It's not wrapped. Okay, so what are the zeros of the function? Remember, the zeros of the functions are my x-intercept. So in here it would be -3 and -2. On the x-intercept, y equals 0. So just look for your where y equals 0. Very good. For here, y equals 0. So 2 equals 2x minus 3. So 0 equals 2x minus 3. Then solve for x, which would be plus 3 on both sides. And I get that 3 equals 2x. And then divide by 2. So the 0 for this function would be 3/2. And then in here, I would just graph it. And then go for that table. So I'm going to go to the I'm going to go to y equal to and turn it on. Wait, I'm sorry. I'm going to go to y equal to, and I'm going to write just like I see it. X plus 5, and the parentheses, x plus 3. And I'm going to go to the table and find my zeros where y equals 0. So, oh, there's one right there, where y equals 0. So it would be x equals -3. Let me go up and see if I can find the other one. Nope. So I need to go down. There it is. Oh, it's right there. I'm sorry. I didn't see it. -3 and -6. So hopefully this is the last one, I think, because this class is a little long. I'm sorry, babies. Thank you for working so hard with me. Okay, so this one's really easy. I'm not even going to finish it. All you have to do is go to g of x and then plug in the x, substitute the x by the number that's inside the parentheses, which would be 10. So this would be -3 times 10 plus 1, which is -30 plus 1, which is -29. So you do that with all of those, okay? I'm going to wrap this up because you guys can do this. I was seeing this when you were doing it and you were fine. Now, this one is a little different because you got to find x if g of x equals 16. Now, remember, g of x is the same thing as y. So in here, y equals 16. So I'm going to go to g of x. And then remember, this is y. So I'm going to plug in that y over there, which is 16 equals -3x plus 1. And then I'm going to solve for x. So that will be -1, 1. That's 15. equals negative 3x. I'm going to divide by negative 3, and x equals negative 5. Okay, so I only did 2 of each. Make sure that you finish that. Most of you already have this, so if you have your paper, you can just go ahead and copy whatever you copy on the paper as well, okay? All right, babies. You guys have a good night. I will see you tomorrow. Sleep tight.